In this video, I'll discuss finding ellipses in cylinders using a method you don't know, and it's in my book, Ellen's Guide to Perspective, on Amazon. Before I get into elliptical subdivisions of cylinders, I first want to show you how to draw a horizontal cylinder. So start with the box in perspective and find the center of the ends using diagonals. Then connect these centers together, and that's going to be the axis of the cylinder. Then put in the ellipses, and this is the hard part. Concentrate on having the minor axis of the ellipse contiguous with the axis of the cylinder. Then the major axis, which is perpendicular, must go like this. A common mistake is to have the ellipse vertical, and that would be wrong. Once you have the two ellipses, you connect the major axes together to find the sides of the cylinder, and then you can get rid of the box. To draw a cylinder using the tire method, overlap two identical ellipses, or make one narrower than the other, keeping the major axes the same length. Then, connect the ends of the major axes together using lines that are parallel to the cylinder axis. Shade the front of the tire, and then finally add this small ellipse on the side so that this length is longer than this length, indicating that the front part of this tire is closer to us than the back part. Here are examples of the minor axis of the ellipse lining up with the axis of the cylinder. So here we have the minor axes of the ellipses in green lining up with the axle of the wheel. And notice that the lines connecting the two ends of the ellipses are parallel to this axle. For the mushroom, the center of the stem lines up with the minor axis of the elliptical cap. And for the daffodil, the axis of the cup lines up with the minor axis where the petals form an elliptical shape. This is one method to draw accurate ellipses in cylinders, although there are much easier approaches. So first, I determine the degrees of the ellipse for the top and the bottom using ellipse templates. So this is about a 15-degree ellipse, and this is a 30-degree ellipse. So if I divided this cylinder into three parts, then this would be eye level. And we could put a 15% degree ellipse here. And just so you know, we're looking down at these ellipses, and we're looking up at this ellipse. In the second method, we're going to divide this line and this line into equal units, but different equal units. You can see that these don't exactly line up. And then the ellipse goes from one of these units to one over here in every case. Now, the problem with this is that you have to have the ellipses on units or multiples of units, but you can work around it. So if, for example, you want an ellipse here, you know it's got to be rounder than this one, but not quite as round as this one. This third method is used often, and I just don't like it. First of all, you need to construct a box, and then the trapezoid where you want your particular ellipse to be. And right away you can see there are lots of lines. Okay, and the other problem is fitting this ellipse into this trapezoid. You can see that a true ellipse will be partly outside, and it needs to be horizontal so that its minor axis is vertical, so it goes, so it aligns with the axis of the cylinder. And it's very hard to put a horizontal ellipse in this trapezoid. So don't use this method. So this is the best method. Drum roll, please. Oh, well, so much for that. I got this from a book from 1892. Sure, you've read it, right? And what we start with are the ellipses for the top and the bottom. We have a line that connects them. And pick a measuring point on eye level, anywhere you want. The further away it is, the flatter these ellipses will be. Then we need to draw another line where these orange lines hit the ellipse here and here. So we have lines 1 and 2. Now we're all set up. We can put an ellipse anywhere. So I put it here, and it has to touch both edges of the cylinder. It has to go through both lines, and points from the lines, going through the lines and going through the center of the ellipse, then goes to the measuring point. There's only one ellipse that will do that. So you can put an ellipse anywhere. There are very few lines that you have to deal with. And remember that this is an ellipse we're looking down at, and this one is an ellipse we're looking up at. For this vertical subdivided cylinder, lines go through the middle of each ellipse and intersect these two vertical lines. As these lines get steeper, you can see that the ellipse is narrow here and much wider down here. But it doesn't change their minor axis, which is still vertical, superimposed on the axis of the cylinder. Now for this subdivided horizontal cylinder, we have two circles, the green one in front and the blue one in back. And these orange lines connect like parts. So it connects the tops, it connects their centers, it connects their bottoms, and so on. Here I tested methods 1 and 4 to see if they agree. Eye level is where this vase opening looks like a line. And the first problem we have is that these ellipses aren't the same size. So you have to transfer them to a cylinder and enlarge them so they become part of the cylinder, meaning the spaces all around here between the original ellipse and the cylinder ellipse is equal. Then for the first method, I divided it into 20 degrees, 25 degrees. This is a 25-degree ellipse. At 30 degrees, and this is a 35-degree ellipse. For the fourth method, I set up this measuring point or vanishing point with lines going through the center of each ellipse and touching these two vertical lines. So I like method 4 the best because there's no math and you can put the ellipses anywhere. For this cylindrical form that recedes, start with finding equal divisions that recede in space using multiplying rectangles. So these divisions get closer together as they go toward the distance. Then erect half ellipses with vertical axes, and you have this half horizontal ellipse that recedes in space. Another approach is to draw this base that recedes and then either surround it by circles or half circles. And this could be, for example, ribs of a boat. And then in this final version, I used multiplying rectangles again. So that means I went from this corner through the middle of this green line to find where this green line begins. And then I put the circles over these green lines. And you can see that it makes this building look like it recedes upward. In my next video, I'll show you how to draw accurate arches using circles. And please remember to subscribe.